Hello children, welcome to Math Park. Our today's topic is Pythagoras theorem and we are going to solve exercise 13b. This exercise is going to be solved in two parts children. So after going through, if you liked it, please share with your friends, and if you are new to the channel, please subscribe. So first question is multiple choice question. You have to choose the correct option over here. Though such questions are there in the exam, you need to actually work out to get the correct values. So you are given a triangle ABC where angle C is 90 degree and AC and BC are two equal sides. So it is an isosceles right triangle. Then AB square is equal to which of these options? Now we know the Pythagoras theorem. So we have AB square is equal to AC square plus BC square. Now since AC and BC are equal, we can, and AC square plus AC square is 2AC square. So this is how our correct option is 2AC square. Got it? So had it been here BC square, I would have taken here as 2BC. In the given diagram, AE square plus BD square is equal to which? Okay. So AE square plus BD square is equal to what? So we use the Pythagoras theorem. We have AE square for this triangle AEC is equal to AC square plus CE square. Then we have, since we have to find BD square again, so we will have BD square. BD is the hypotenuse of triangle BDC. So you get BD square is equal to DC square plus BC square. Let us add these two equations. So we have AE square plus BD square is equal to AC square plus CE square plus DC square plus BC square. Now look at the options what all are given here and check which is applicable. Now AC and AC square plus BC square, you are going to get AB square. So AC square plus BC square, you get it as AB square for the whole triangle ABC. Okay, so AB is the hypotenuse over here. Then what is left is CE and DC. So CE and DC here, the hypotenuse, these are the parts of triangle DCE. So CE square plus DC square, you get plus DE square. Okay, that is how you get AE square plus BD square is equal to AB square plus D square. This is the correct option. C part of this, in the given figure, the value of AB times CD is what? Now look at this triangle here. Now area of this triangle can be found out in two ways. It's a right triangle. So area of this triangle is going to be half of the base, which is AB, into the altitude is CD. And area of this triangle is also half the perpendicular sides, which is BC into AC, right? So half got cancelled. So what do you get? AB into CD. AB into CD is same as BC into AC. So this is the correct option, BC into AC. So ABC is an isosceles triangle right angled at C. So it is right angled at C and it is an isosceles triangle. Okay. An isosceles triangle right angled at C. This is a right angle over here. Then 2AC square is equal to what? Okay, is equal to what? So it is an isosceles triangle. We know that by Pythagoras theorem, you have AB square is equal to AC square plus BC square. Now, since AC is equal to BC, you get this as 2AC square because in place of BC, we can write it. So AB square is equal to 2AC square. So which one is equal to? So it is AB square is equal to. Then 2AC square is AB square. Got it? So this is how we have done the multiple choice question. We start with the second question of this exercise 13b. In the given figure below, you have AD is perpendicular to BC. You have to prove C square is equal to A square plus B square minus 2AX. Okay, now we can apply the Pythagoras theorem for two triangles over here. So if we apply the Pythagoras theorem for triangle ADB, you have a C square, which is the hypotenuse, is equal to A minus X, BD square, which is A minus X the whole square plus H square. Let us expand this. So we have A square, A minus X the whole square, A square minus 2AX plus X square plus H square. Okay. Now let us look at the triangle. So we have in triangle ADC, we have, this is our equation number 1. Let us take in triangle ABC, B square is the hypotenuse. So B square is equal to H square plus X square. Okay. So now can we put here, this is equation number 2. So in place of H square plus X square, we will be now putting B square. So we can say from 1 and 2, you get C square is equal to A square. In place of H square, X square plus H square from 2, I'm going to put B square and this minus 2AX. And hence proved, we have done with question number 2. Moving to question number 3. In an equilateral triangle ABC, AD is perpendicular to BC. So, and BX is. So, let us draw this triangle. In this equilateral triangle ABC, you have AD is perpendicular to BC and BC is equal to X. Find in terms of X the length of AD. Okay, so let me take the length of AD. This is your H. Okay, and since BC is equal to X, we know that the altitude of an equilateral triangle divides the base into 2 equal parts. So this is how you get this as X by 2 and X by 2. Right? Now find BD. So let us use the Pythagoras theorem for any one triangle. So we use in triangle ADC. Instead of H, I'm going to write here AD only. So AD square, if I find AD square is equal to AC square minus DC square. Okay. Now all the sides are equal. Since it's an equilateral triangle, you get AC also as X. So AD square is equal to AC, which is X square, minus DC, which is X upon 2 the whole square. So it is X square minus X square by 4. Take LCM. So 4X square, you'll have to multiply by 4 and divide by 4 here. 4 minus 1, we get 3 by 4X square. Take square root. So this is your AD square. Now take square root. So taking square root, you get AD is equal to X root of X square is X. So root 3, root of 4 is 2 and X. This is how we have found the length of AD in terms of X. Got it? Moving to question number 4. ABC is a triangle right angled at B. So let us have a triangle here. So ABC is a triangle right angled at B. And M is the point on BC. So there is a point M on BC. You have to prove that AM square. So let us join AM. So AM square plus BC square is equal to AC square plus BM square. Okay. AM square plus BC square is equal to AC square plus AM square. So M is any point on BC. So let us target AM square. So let us start with the proof. So we have AM square is equal to AB square plus BM square. Okay. Then we have BC square. We are using the whole triangle here. So BC square is equal to hypotenuse, which is AC square minus AB square. Let us add these two equations. So this is my 1 and 2. So we add here equation 1 plus equation 2. You get AM square plus BC square is equal to AB square. Let me write here AB square plus BM square plus AC square minus AB square. And you get AB square minus AB square got cut, and this we are left with AC square plus BM square. So thus we get AM square plus BC square is equal to AC square plus BM square, hence proved. Moving to question number 5, it has several sub parts here. So M and N are the midpoints of QR and PQ of a triangle PQR right angled at Q. So Q, PQR. Okay, M and N are the midpoints of QR. So M is the midpoint of QR and N is the midpoint of PQ respectively. You are supposed to prove PM square plus RN square is equal to 5MN square. Okay, so PM, so let me join this PM square plus RN square. So I'm joining this RN. We are doing the first part of it. So let us take PM for using PM square. Now you have to bring this in terms of MN. So target should be what? So PM square, and it's a midpoint. Since it is a midpoint, now we have to target MN. So focus on this part. Okay, we have to focus on this MN part. So when we talk of MN, in this right triangle NQM, we have QN and QM are the parts of triangle QNM. So we will be targeting this when we are using PM square. Okay, so in this triangle, in the triangle PQM, we have PM square is equal to PQ square plus QM square. Okay, but PQ can be written as twice Qn. So we can write it as twice Qn the whole square plus Qm square. Okay. Now twice Qn the whole square is 4Qn square plus Qn square plus Qm square. Okay, we simplified this part. Now let us go for Rn square. So we now use Rn is an hypotenuse of triangle NQR. So in triangle QNR, you have Rn square is equal to Qn square plus QR square. Now QR can be written as 2QM. So this is how you get this as Qn square. Let us write it as Qn square only. And QR square can be written as instead of QR, I can write 2QM. So 2 plus 2QM the whole square. So which is Qn square plus 4QM square. Got it? Now this was my equation number 1 and this is my equation number 2. So now since we have to find PM, we have to prove PM square plus Rn square is equal to 5Mn square. Let us add these two equations. So we get PM square plus Rn square is equal to 4Qn square plus Qm square plus Qn square plus 4Qm square. Got it? We just added this. Now, Qn, 4Qn square plus, let me solve up there. I don't have enough place here, so I'm solving it up here. So we have, let us add this like term. So we get 4Qn square plus Qn square. We get 5Qn square. Qm square plus 4Qm square. We get plus 5Qm square. So this is equal to 5 taken back in common. We have Qn square plus Qm square. And in triangle NQM, Qn square plus Qm square is nothing but Mn square. So this is how this is 5Mn square. So thus we have proved Pm square plus Rn square is equal to 5Mn square. Got it? So we have done with the first part. So we have to prove 4Pm square. So let me join this Pm and is equal to 4PQ square plus QR square. So 4PQ square plus QR square. So what all right triangles are possible there? So we have these 3 right triangles over here. Okay. So let us take the LHS of this equation. Okay. So second part we are taking 4PQ square plus QR square. Okay. Now PQ is the part of this triangle and we are targeting PM square. So let us use the triangle PQM over here. So 4PQ square. Instead of PQ square, we can write it here PM square minus QM square. Okay. PQ square. Instead of PQ square, we have PM is the hypotenuse here and QM. So that is how you get PQ square is equal to PM square minus QM square. For QR square, let us write it as simply plus QR square over here because which is required QR square as it is. Okay. Now 4PM square minus QM square. So what is QM? Now we have to target what? We have to target, we need to get PM over here. So PM, if you want, this QM can be written in terms of QR because QR is over here. So we write QM in terms of QR because M is the midpoint. So we get 4 in bracket PM square minus QM square. So QM is nothing but half of QR. So it is QR upon 2 is what is QM square plus QR square. So we get this as 4 PM square minus 4 times, this is going to be QR square upon 4 plus QR square. So you got this 4 cancel, QR square minus QR square got cancelled, and we got this as 4 PM square and hence proved. So this is how 4 PQ square plus QR square is equal to 4 PM square. Done with the second one, let us start with the third part. Let's start with the third one. Third one, we have 4Rn square. So 4Rn square. So Rn is the hypotenuse of triangle QNR. So we have Rn square is equal to Qn square plus QR square. So instead of Rn square, now let us write down 4 bracket Qn square plus QR square. So you have to target. Now QR square is already here. Qn you need to get rid of and we want PQ here. So how can you write Qn in terms of PQ? We know that n is the midpoint of PQ. So instead of Qn, we write PQ by 2. So 4, instead of Qn, we are writing PQ upon 2 the whole square plus QR square. Okay. Now let us simplify this further. 4 PQ by 2 the whole square is going to be PQ square upon 4. We are multiplying by 4 simultaneously plus 4QR square. So this 4 got cancelled and we get PQ square plus 4QR square. This is how we get 4Rn square is equal to PQ square plus 4QR square. Sorry, PQ square plus 4QR square. Got it? So this is how we have done with the third part. Let us start with the fourth one. Let's start with the fourth one. So we take the L this part. Okay, now we have PM square is equal to PQ square plus QM square. And we have Rn square is equal to Qn square plus Qn square plus QR square. Now this we will be substituting in this equation, but we obtained everything in terms of PQ and QR because we have to prove here PR square. So PR is the hypotenuse of the bigger triangle. So PQ square is already over here. Instead of QM, what can I write? So this can be written as PQ square and QM is nothing but half of QR. So plus QR upon 2 the whole square. So which we get it as PQ square plus QR square upon 4. Okay. Now same way, let us simplify this Rn square. So in Rn square, we have Qn square. QR is already there. Qn we'll write in terms of PQ. So Qn is nothing but PQ upon 2 the whole square plus QR square. So which is PQ square upon 4 plus QR square. Okay. Now let us take this part. So we have 4 in bracket PM square plus Rn square is equal to, let us write down whatever we have got over here in the first and the second part. So we have PM square is equal to 4 bracket PQ square plus QR square upon 4 plus, sorry, this was all inside the bracket. So, yeah. So, plus PQ square upon 4 plus QR square. Right? Now, let us simplify this. Multiplying by 4 throughout, we get 4 PQ square. 4 and 4 will get cancelled. We get plus QR square plus this 4 and 4 will get cancelled plus only PQ square and plus 4QR square. So now this QR square plus 4QR square is going to be 5QR square and 4pq square plus pq square is going to be plus plus 5 pq square, and this is all what is equal to, it is equal to 4 pm square plus qn square. Now let us take 5 common here, pq square plus qr square. Now pq square plus qr square is nothing but pr square, which is the hypotenuse for triangle PQR. So thus we have proved 4 pm square, 4 bracket pm square plus rn square is equal to 5 pr square. Done with question number 5. Next video will be coming up with the remaining questions of this exercise. Children, if you like it and if you feel it is useful, please share with your friends. And if you are new to the channel, please subscribe. Thank you for watching. Have a good day.